After a survey at a large university, they found that 47% of their student body were female, that 47% of their student body are in-state students, 36% live in dorms, 12% are female students living in the dorms, 15% are female in-state students, 14% of those living in the dorms are in-state students, and 5% of female in-state students live in the dorms. And we want to know what's the probability of selecting a male who is an out-of-state student and who doesn't live in the dorms. Now to solve this problem, we're going to have a 3-circle Venn diagram, and our 3 circles are going to be female students, those students living in the dorms, and the students who are in-state students. When solving a probability problem with a Venn diagram, it's always best to start with the most restrictive event, which in this case is the 5% of female students who are also in-state students and live in the dorms. This is represented by the very middle of the Venn diagram, which is the intersection of all 3 circles: the freshman circle, the students living in dorms circle, and the in-state student circle. Now, since this is the only part of the circle that's included in it, we can just go ahead and take the 5% and plug it into our Venn diagram. So that very middle section is 5% of our population. Now that we have this calculated, we can go ahead and go to the next item, where 14% of the students living in dorms are in-state students. This is the intersection of the students living in dorm circle and the in-state student circle only. So we look at that, and that does include this 5% that we've already computed for of the female students who are in-state students who live in the dorms. So we take the 14%, subtract the 5% that we already have, that gives us 9% for this next piece in this next region. Now going on to the next one, where 15% of the female students are in-state students. That's the intersection of the female circle and the in-state circle. And so we go ahead and take the 15. It does include that 5% we've already included, so we subtract that out, giving us 10%. Next, we'll look at the 12% of female students who live in the dorms. This is the intersection of the female circle and the dorm circle. It does include that 5%, so take the 12%. Subtract out that 5% that we've already figured out, leaving us with just 7%, which we can put in the last region. Now going to the next step up, where 36% of the population lives in dorms, that's just the dorm circle, which includes the 3 numbers we've computed, the 7%, the 5%, and the 9%. So adding those together give us 21%. So we take the 36%, subtract the 21% we've already taken into account, and that gives us just 15% remaining. So that goes in this region here. Now that we've figured out the entire dorm circle, we'll go ahead and move to the next one, which is 47% of our student body is in-state students, and that's the in-state circle. It does include the 3 values we've already computed, the 10%, the 5%, and the 9%. So adding that together give us 24%. So we take our 47%, subtract the 24% that we've already taken into account, leaving us with just 23%, which we can go ahead and put in this region of our in-state student circle. Moving on to the last number on our list, that 47% of our student body are female. That's just the female circle here, which does include the 7%, the 5%, and the 10% we've already included. So adding those numbers together give us 22%. We take the 47, subtract the 22, and that gives us 25%, which we put in this last region here. Now that just leaves us with what's outside of the 3 Venn diagram, which would be male students who don't live in the dorms and are not in-state students. So we go ahead and add all of the numbers in the Venn diagram up, and we get 94%. Now, the sum of all our probabilities is always 1 or 100%. So we take 100%, minus 94%, and then that gives us 6%, which is the amount of male students who don't live in the dorms and are not in-state students.